Preparing for a data engineering at Goldman Sachs interview? You've reached Candy Mentor, and this video is for you. We'll walk through 15 key questions you're likely to face. For each question, you'll see a sample answer, followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you use SQL window functions to deduplicate trade records or calculate running metrics? Window functions calculate values across related rows without collapsing the result set. I use them for rank, running totals, deduplication, and point-in-time analytics. For example, row number over a customer partition ordered by trade time helps keep the latest trade event. Unlike group by, I still retain row-level detail. In finance, that matters because downstream reconciliation often needs both aggregates and original records. I also specify tiebreakers to avoid inconsistent results across reruns. While answering, focus on window functions versus group by. Common functions like row number and rank, partitioning, ordering, deduplication use cases, and why deterministic tiebreakers matter in financial data. Question 2. How would you design a data model for a trade and analytics platform? The main risk is modeling for both correctness and query speed. I would separate immutable trade events from curated trade facts, with dimensions for instrument, counterparty, book, trader, and calendar. Facts would store measures like quantity, price, notional, and timestamps. I would use surrogate keys, effective dating for slowly changing dimensions, and partition by trade date. That supports regulatory auditability while keeping analytics performant at scale. Make sure to cover fact and dimension tables, trade events versus snapshots, surrogate keys, slowly changing dimensions, partitioning by business date, and audit requirements common in investment banking data platforms. Question 3. A Spark job processing market data is running slowly. How would you troubleshoot and optimize it? I start by checking the execution plan and the Spark UI, not guessing. Common fixes include pruning columns, filtering early, choosing efficient file formats like Parquet, and tuning partitions. If joins dominate, I broadcast small dimensions or handle skew with salting. I also avoid wide transformations when possible, and cache only reused datasets. The goal is lower shuffle, balanced tasks, and predictable resource usage costs. In your answer, talk about reading execution plans, Spark UI, shuffles, skew, broadcast joins, partition sizing file formats, caching discipline, and how optimization choices reduce cost and runtime. Question 4. What does idempotency mean in ETL pipelines, and how would you implement it? Idempotency means rerunning a pipeline produces the same correct output, not duplicates or drift. I design it with deterministic keys, upserts or overwrite by partition, checkpointing, and clear run metadata. For example, a daily trades load should replace that business date atomically after validation. I avoid appending blindly. In banking systems, idempotency is critical because jobs are often replayed after upstream corrections or late reference data changes. Be sure to mention deterministic primary keys, upserts, atomic writes, overwrite by partition, checkpoints, reruns, duplicate prevention, and why idempotency is critical when regulated data pipelines are replayed. Question 5. When would you choose batch processing over streaming for financial data pipelines? Batch is best when latency tolerance is minutes or hours and data can be processed in bounded chunks. Streaming fits use cases like fraud signals, market events, or intraday risk where freshness matters. I evaluate SLA, ordering, volume, failure recovery, and cost. Streaming adds complexity around state, exactly wants semantics, and back pressure, so I do not choose it unless business value justifies operational overhead clearly exists. While answering, compare latency, throughput, ordering guarantees, operational complexity, business SLA, failure recovery, cost, and examples like fraud alerts, market events, end-of-day reporting, and risk calculations. Question 6. Explain Kafka partitioning and consumer groups in the context of a real-time trade ingestion system. Kafka gives durable, ordered logs within each partition. I would explain producers, topics, partitions, consumer groups, offsets, and retention. Ordering is only guaranteed per partition, so the key choice matters. For trades, Trade ID or account ID may be appropriate depending on processing logic. For reliability, I use acknowledgements, retries, idempotent producers, and committed offsets. Exactly once requires careful integration with the sync and transactional write patterns too. Make sure to cover Kafka topics, partitions, keys, consumer groups, offsets, ordering, replayability, delivery semantics, idempotent producers, and how partition key selection affects downstream financial processing. Question 7. How do you implement data quality checks in a production data pipeline? I treat data quality as a first-class pipeline stage, not a dashboard afterthought. I validate schema, nullability, uniqueness, referential integrity, ranges, freshness, and reconciliation totals. In a Goldman-style environment, control totals for trades, cash balances, or positions are essential. Failed checks should quarantine data, alert owners, and preserve lineage. Good quality controls reduce downstream breaks and regulatory risk, and make incidents easier to investigate quickly. In your answer, include schema checks, null handling, uniqueness, referential integrity, freshness, reconciliation totals, quarantine tables, alerts, lineage, and why data quality controls reduce operational and regulatory risk. Question 8. What is a slowly changing dimension type 2, and why is it useful in financial reporting? Slowly changing dimension type 2 keeps history by creating a new dimension row when an attribute changes. I typically use effective start date, effective end date, current flag, and a surrogate key. For example, if a client risk rating changes, historical trades should still join to the rating valid at trade time. This supports auditability and point-in-time reporting, but it increases storage and join complexity, so indexing is important for performance. Be sure to mention current versus historical records, effective dates, current flags, surrogate keys, point-in-time joins, auditability, and the trade-off between historical accuracy and query complexity. Question 9. How would you process a very large CSV or JSON file in Python without running out of memory? For large files, I avoid loading everything into memory. I stream rows with generators, process chunks with pandas or PyArrow, and push heavy transforms to Spark when data exceeds single machine limits. I also define schemas explicitly, handle bad records, and write columnar outputs. In interviews, I mention measuring memory, not assuming. The right approach depends on file size, transformations, and SLA and downstream consumers too. While answering, focus on streaming reads, generators, chunking, explicit schemas, compression, PyArrow or pandas limits, Spark handoff, memory profiling, and safe handling of malformed records. Question 10. How would you design an Airflow DAG for a daily positions and trades pipeline? Airflow is an orchestrator. It should coordinate work, not perform heavy computation inside tasks. I design DAGs with clear dependencies, retries, timeouts, SLAs, and idempotent task logic. For a trade ingestion workflow, tasks might extract, validate, transform, publish, and reconcile. I use sensors carefully because they can waste resources. Good DAGs are observable, parameterized, and easy to rerun safely after failures or backfills in production. Make sure to cover DAG structure, dependencies, retries, SLAs, sensors, backfills, idempotent tasks, parameterization, observability, and why orchestration should not hide heavy processing logic inside tasks. Question 11. What is the difference between a data warehouse, data lake, and lakehouse? A warehouse is optimized for governed, structured analytics with strong SQL performance and curated schemas. A data lake stores raw and semi-structured data cheaply, while a lakehouse adds table formats, ACID transactions, and schema enforcement on object storage. I would use raw zones for ingestion, curated zones for trusted datasets, and warehouse marts for business reporting. The design balances flexibility, governance, and query performance requirements. In your answer, compare warehouses, lakes, and lakehouses across schema enforcement, ACID transactions, raw versus curated zones, governance, cost, SQL performance, and analytics consumption patterns. Question 12. How does change data capture work, and what issues can occur when applying CDC to target tables? Change data capture moves only inserts, updates, and deletes from source systems instead of reloading full tables. I look for log-based CDC when possible because it is efficient and less intrusive. The pipeline must handle ordering, duplicate events, deletes, schema changes, and replay. For targets, I usually merge into a curated table using primary keys and watermarks. CDC is powerful, but operational monitoring is mandatory. Be sure to mention log-based capture, inserts, updates, deletes, primary keys, watermarks, ordering, replay, schema drift, merge logic, and monitoring for source-to-target consistency in production. Question 13. How do partitioning and clustering improve query performance in large analytical tables? Partitioning reduces the amount of data scanned by physically organizing data on common filters, such as train date or region. Clustering or bucketing improves locality for joins and selective predicates. I avoid over-partitioning because many small files can hurt performance. For financial datasets, date partitioning is common, but I validate it against real query patterns. The best key is workload-driven, not guessed or copied from templates. While answering, focus on partition pruning, clustering or bucketing, common filter columns, join patterns, small file problems, over-partitioning, query workload analysis, and performance impact at scale. Question 14. How would you handle late arriving or corrected trade data in a pipeline? Late arriving data is normal in distributed pipelines, especially when upstream systems batch, retry, or correct records. I handle it with event time, watermarks, reprocessing windows, and partition-level upserts. For reporting, I separate preliminary numbers from finalized numbers so users understand stability. If a late trade affects yesterday's position, the pipeline should adjust that partition and record the correction. Transparency matters as much as correctness here. Make sure to cover event time versus processing time, watermarks, reprocessing windows, upserts, backfills, correction records, stakeholder communication, and consistency of finalized reports after changes. Question 15. Tell me about a data engineering project you built end-to-end. What trade-offs did you make? I would structure the story around business impact, architecture, and trade-offs. For example, I built a pipeline that ingested transactions, validated them, transformed them in Spark, and published curated tables for analytics. I would highlight scale, latency, failure handling, data quality checks, and how I monitored production. Then I would quantify impact, such as reduced processing time or fewer reconciliation issues. Strong answers show ownership, not just tools. In your answer, structure the project around business problem, architecture, scale, tools, data quality, failures handled, monitoring, measurable impact, trade-offs, and your personal ownership clearly. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we're able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.